7 of code. I am now thankfully back in New York. I'm super happy about that. So we'll be getting started with day 20. I just did a quick get pull in order to synchronize the work that I'd done in San Francisco and Seattle to here. So we should be ready to take a look at the problem and also do our boilerplate stuff. All right. All right, let's have a look over here. So, we're learning about instruction pointers and doing machine language stuff. We're in a area of room and doors. Yep, okay. Ha ha ha! Oh my god. This is hilarious. So we have to find all possible routes that match the regex. Yep. And the pipes contain, yep, okay. Yeah, I know how regex could work. Okay. So we need to be able to follow all routes that are feasible and then mark all of those as available or not. Right. Okay, so that indicates that there are multiple ways to get detours. Okay, and we need to know which room is furthest from us. The shortest path to require passing through the most doors. Okay, we know how to do that. That's just a, because the route distance is fixed, that's just a breadth first search, so that's okay. What's the largest number of doors you could be required to reach a room starting from the starting place? Great. Okay, so let's get our puzzle input, which is, ooh, goodness. Okay. That's a little bit bigger than I was imagining. Let's see how that goes. Okay, yeah, that's one giant regex. Let me take a guess that maybe doing a 4 to the nth power solution is not going to work here. This is actually the first time that I've genuinely been head-scratching about what the right algorithm is to solve this. So that's good. Okay. Well, let's do what I would do if I were in a coding interview, which is, let's do the naive solution, and then let's iterate on it, just to make sure that we understand it, and we can reuse the parts that make sense. And we can not use the parts that don't make sense. So let's do that. Okay. So I'm going to feed in this as my simple input. Just so I have that handy. And let's, we're not going to need integer conversion. We probably will need strings. We almost certainly will need regex. Okay. Okay, and we don't yet know whether we're going to need a part B logic or not. Okay. All right. So let's go look at the regex documentation. We need must compile. Okay. So theoretically that should work. So we're going to need to define some data structures and then get to work here. This is indeed the first time that I've been stumped by a puzzle, and I'm just trying to think through all of the implications. Okay, so how do we do this? I guess what we can do is we can... The problem with concatenating the strings to build up to see whether they match or not is you could have a situation where you can't rule out something because extending it would cause it to match, but leaving it at the current length would not cause it to match, and I don't know what to do about that. Okay, well, let's write the sketch of an algorithm and try to figure out how we can do this. So basically, we need to kind of build up a list of potential paths. And then we need to verify that each path matches the regex. And then after that, okay. Something like that. And for each path, what we need to do is we need to evaluate which doors it passes through, which means we're going to need some kind of a coordinate system. All right, let me think about this. How do we work this? So each room needs to keep track of what the exits from it are. So something like that, and then that's just going to be, I could store it as a bit field, but I suspect that it's not going to be too big, so we'll just keep this as a string. Okay. Yeah, that'll be fine. Okay. Like that. And then we can then, okay, so going to have I'm really curious. I'm going to slightly cheat on stream, and I'm going to look at how long it took other people to solve this. Ooh, only 1680 people have solved this so far, and the fastest it took someone to solve was 17 minutes. And the slowest, yeah, okay, 17 minutes. Well, the good news is that means that Part B is not much harder than Part A. Top 100 took 2 hours. Okay, or took 1 hour. So I think maybe I can get it done in 2 hours, but we'll find out. Hi, Francisca. Have you done day 20 yet? Because this is stumping me a little. I have literally been working on part 1 of day 20 for, we'll say 5 to 10 minutes, and I have no idea how to approach the difficult part of the algorithm. I know how to do the simple part once I know kind of what the output of the mystery box is, but I don't know how to generate the mystery box output, so we'll figure that out later. But for now, I want to write down the thing I know how to do. Let's see. Okay. I think adjacencies initializes to the empty string because every map type always initializes to the empty variable, so that's fine. So let's see. Something like that should do the trick, and then otherwise, I can break out. That should do it. Okay, now let's see. Yeah, it seems fine. Wait. Coordinate system trouble. Do the trick. Alright, so now we've torn down all of the walls that we need to tear down. And we need to tear down the wall in the opposite direction as well to maintain the bidirectionality of it. How do I do that? Okay. Crud. How do I do that? Okay. Okay, well, the easiest way to do that is to move this logic elsewhere. That should do it. Okay. I don't think they specified that they're one-way doors, that if you can get from point A to point B, you can get from point B to point A. Okay. Fine. Okay. 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 That seems about right. Okay. I think that makes sense. Okay, so now I've done that. Let's see, what do we do next? I think we do next doing the breadth first search. And you'll notice that I'm continuing to punt doing the difficult part, but that gives me more time to percolate on it. Okay, actually, I think I have some ideas as to approach the regex. I think the right thing to do is to structure it as a tree, so I'm going to think about this. Okay. That makes sense to me. Okay, so now let's see this. Need a queue. Okay. Actually, I can just statically initialize that. Okay. So, how do we approach this? We're going to flood fill as we go. So, for flood filling, we also need to do something that generates the adjacent coordinates. Okay. That, and then something like this, except for not quite, should do the trick. All right. that. And then copy the coordinate. And then that should do it. We have the adjacencies. Do our queue management. And in order to be breadth first rather than depth first, we need to make sure that we're always appending to the end of the list rather than to the beginning. Okay. How do we do this? Okay. Okay. And we need to avoid going backwards. Do we need a custom data structure to remember how far we've gone? Yes, maybe. No, I can set my termination conditions correctly. No, I do need, okay. Let's see. Great. Okay, how and then we skip processing this, that's fine. Oh. Yeah, that avoids that problem. Okay, so if we've seen it already, we continue. Otherwise, we do that, and then Oh. Do it. Okay. Okay, that should do it. Now, what do we need to do? We need to... Let's see. Right. I think that should do it. Good. Okay, that should terminate. Now we also need to consider okay. So I think that should do it. Now we need to build the list of paths. So this is the tricky part I was deferring. Okay. I just want to find whether it matches at all. Nice. Nanopsychopaths. I approve. Who's the other nano user, out of curiosity? Okay, let's see. In the meanwhile, okay, so let's think about this. Okay, I could hypothetically have multiple pipes. Can I have multiple pipes? Yeah, I can have multiple different potential branches. Yeah, I can potentially have multiple branches. Okay. Okay. Let's see. Okay. Let's see how we think about this. Anthony writes code. I'll have to look them up later. Thank you. Let me open up that in my browser to bookmark later. And make sure they're currently not streaming. Good. Okay. Great. All right. So we have, I'm just going to keep this close by. Oh, I can have both children. I can have both children and siblings, can't I? Right, because either I have multiple components to the path, as well as siblings. Ugh, that's the worst. Okay, I wish I'd studied regexes more in school, but unfortunately I did not. I think about this. So I may have children that I need to resolve. So it's obvious that a leaf contains the empty string as the payload and no substrings. But the payload could also be a sequence of other path strings. Okay, so I think we have to iterate these until we encounter a null payload. Let's think about that. So see this. Okay. Because I can imagine having a payload potentially consisting of a payload, some branches, and then another path substring that comes after it. Okay, my nose is running. I'm going to go grab a tissue real fast. Let's see this. Okay, so just going to call that raw instead, that's going to become really cumbersome. So if it is, we know that it's always going to start and end because of this special case. We know that it starts and ends with the, no thanks Google, I don't want to translate. We always know that it starts with the caret and ends with the $sign. So I'm just going to trim those preemptively. Either it is okay. Or we have that, or we have this, or we have this. Okay. Okay, this could just actually be... Okay, that's actually fine. Okay. Now, if it's a character... path substring. Does that work? I think that might work. I don't know whether that works or not. I don't know whether that's a Pythonism. Okay, that looks fine. That looks fine. Okay. So in this case, we know that we want to append that rune. If it is an opening group, then we know we need to keep track of our parents as well. Okay. That seems fine. Can a parent be either? Yeah, I think that's okay. Let's see. Branches. So effectively kind of what this is this is an OR. Okay. Cannot believe that someone managed to do this in 20 minutes, because I am really, really, really struggling, having been working on this for about half an hour. Okay. All right, that should do it. Alright, similarly, if we encounter here... I guess this is kind of like, a lot like setting up a parse tree now I think about it, that my compiler's class actually was a class in this, even though it wasn't explicitly a class in regex's. Let's see, I may have to run to dinner in a bit. Dinner logistics are always fun. All right. So in case we encounter a close brace, then that means that there may be other things that need to go after it. So we need to evaluate that possibility. So that should do the trick. And then let's see. Next sibling. Okay. Yep, that makes sense. Oh, I see. Right. Okay. Okay, I think that should parse it correctly. Let's try this. Oops. I'm just gonna stop the code here. Oops. All right. Line 26. What's that? Line 26. Oh, whoops. There we go. Line 57. Non-declaration statement outside of function body. What? Oh. I think that should do it. Do I have too many braces? Yeah, I've got too many braces. Okay. Okay, line 28. Right. 36. Oh. All right. Oh. Okay. That doesn't need to be super efficient. Okay, fine. Okay. Line 42, slowly working through all these compilation errors. Oh, there we go. Line 74. That should do it. And then 86. Ah. Excellent. Getting there at 93. That's where this is always the most difficult part. Oh. Right. Okay. 108. Right. 101. All right. There we go. 113. All right. Where else did I mess this up? Oh, whoops. Okay, let's define that, and 161. Oh, that means that. Let's see, line 171. Flurry, shush, 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 shush. Flurry, hey, get your nose out of there, please. Thank you. Okay, let's see. 71. Oh, yep. Finally, and 181. Oh, yep, I already solved that. Okay. 167. Yeah, we don't care about the value, because if we've seen it, it's by definition shorter or equal in distance. Alright, line 113. Oh. Current parent branches. Right. All right. Let's look at simple input. Okay. So that looks relatively straightforward, you'd think. Let's see. So I need to deal with the case that in the root node, the root node has one pattern matching group. Current parent. Okay, that's weird. That's essentially... Okay. Oh. I see. We should never have to run a parent operation on the root, but I think I'm just not setting parent here. Oh, yeah. Yep. That should do it. Nope, still not quite right. So line 114. Okay, so let's print out as we go. Oh, that's not bad. Okay. I want to print a rune. How do I print just a rune value? I think that. Okay. Let's make sure that that matches. Okay, so we get here, we open the group, and here's where current should have been swapped out and was not when we opened this. Right. There we go. Okay, now let's try running it. That looks pretty good, actually. Okay, so let's have a look at this. So that's that pattern. And then we've got 2 inner patterns. Yeah, I think that looks good. All right, let me just coordinate with my household about dinner. Okay, no, we're not dinner yet. Great, okay, so now we've parsed this into a tree, which I believe works. Okay. I like having verbose debug flags just in case I need them, so I don't wind up rewriting the same code over and over again. Okay. Root declared not used, that's fine. Okay. Great. Okay, so now we can run this code next. I think that may be my spouse getting home, in which case I'll have to resume doing this in about an hour or two. Dog. Okay, hello. So now...
I'm back.
Hey, Ellie.
Hey, dinner.
Dinner? Okay.
Where? You suggested 2
all right,
places.
yeah, let me go ahead and put this aside, and I will think about it over dinner, and I'll come back in a couple of hours.